Okay, this is exercise 2, question C, 1 and 2. Let's start with 1. So I've drawn 3 triangles at the bottom, and I like to start with the gray one, the one that's on the horizontal plane. Then I noticed that the question BC is on the horizontal plane, so that makes me think, okay, I've inputted everything, and what I've done is I broke my 3-dimensional shape into pieces. Start with the beginning. Vertical line means I have a 90 degrees there, which is kind of important. Then I put all my angles in. I have alpha here, I've got beta there, I've got gamma there, and I've got theta over there. So great stuff. Question 1 says prove that BC is equal to the fraction. So since BC is over here, normally I don't start where I want to end. I go to the one that's similar. And I can see that this blue is similar. So I'm going to go to the third triangle. And I'm going to try and work out the blue there. Because this is going to get me closer to getting to line B, right? So let's see what we can do over here. To get BD in the third triangle, let's say in triangle ABD. This is my third triangle, that one. What are my options? Sokotoa? Yeah, I could do Sokotoa. Or I could use the sine rule. Let's try the sine rule and see what happens, because I want BD, right? So BD divided by sine of theta should be equal to, I'm going to use AB divided by sine of 90 degrees. This works out because that AB can be swapped out with X. So this means that BD is equal to X sine of theta divided by sine of 90 degrees. Beautiful. So far, so good. I've got my BD. BD is X sine 90, sine theta over sine 90. Okay, so what is sine of 90? If you do know your special angles, you would know that that is actually equal to 1. So that's perfect. Okay, next up we are going to look at transferring it this way, right? So hold on. Okay, I can write here BD equals X sine theta. Okay, so now I have X sine theta here and X sine theta there. On my answer, I've got one part already, so I'm looking for 2 more, it seems. Let's go to our next triangle. So we've done triangle 3. Let's go to triangle 2. So what do you want to do in triangle 2? Okay, in triangle 2, we want BC. That's what we're looking for. If we did BC, then in the sine rule, it would be yellow with this yellow angle, and it would be blue with that blue angle. So let's write that out. If we use the sine rule in triangle CBD, sine rule, BC, that's where I want to end. So I'll make that my numerator, divided by angle D in this triangle. Sorry, sine of D is going to be equal to the blue, which is BD, divided by sine of beta. Okay, so if I want BC alone, it would be BD multiplied by sine of angle D divided by sine of angle beta. Okay, let's input the values we know. We know what BD is. BD is X sine theta. So BC is equal to, let's do that, this we're replacing with this, which is X sine theta. That's BD. We're going to multiply that with sine of D. Now, what is angle D? Let's talk about that. To have angle D is equal to 180 degrees minus alpha minus beta. Okay, or you can write it as angle D is equal to 180 minus alpha plus beta in brackets. Both of those two are true. Let's go back to the top. Oh, they want a plus statement. So if we're looking at angle D, we're going to use a plus statement over here. So if we're using the plus statement, we're going to go with that one. Okay, so let's substitute. Times sine of 180 minus alpha plus beta in brackets. Okay, this is all too close. I'm going to move this a little bit. Okay, that's equal to D. Separate that. Okay, so we've got sine of D. We've taken that is our D angle from over here. And then our denominator is going to be sine of beta. Does this look like what we wanted yet? Not yet. Okay, so that sine of beta is fine because it's here. So we can go like purple. That's there. So that's fine. The only thing is now that yellow one isn't quite what we want it to be. So now if you're using your reduction formula, you will know that, let's keep this x sine theta and sine of beta. If you're using your reduction, we know that 180 minus whatever angle is in quadrant number 2, and sine is positive. So this reduces to just angle A. So here, this sine is positive, and we keep that portion, alpha plus beta. And there you go. That's the answer to the question. You have proven it. Well done.